right, well, I'm going to kick it off. So thanks everybody for joining us today on for our DoK Town Hall, which we host every Thursday, third Thursday of the month, except for next month, which I'll go over later. We're doing it on Wednesday. Um, but today we have our special guests from Intuit. We have Sri and Vigith. We talk about Numaflow. So we've had them on before, but they're going to talk about some of the latest things going on in Numaflow. Before we bring them on, of course, I have to do some community announcements. So we have the DoK community sponsors. I just want to give a special thank you to our platinum community sponsors, EDB. As always, we really appreciate your sponsorship to allow us to do the community events that we do, like these town halls, and to be involved in things like KubeCon and DoK Day at KubeCon. So really just want to give a special thanks to them. Yeah, also, it's our DoK Day 2025. Thanks to all our speakers and to our sponsors for that event. That just wrapped up, a few months ago. So again, thanks to EDB as a event sponsor and also to Prefect. Exciting, all of the talks are now available on YouTube. So as all of our talks, we post them on the DoK YouTube channel. I put a QR code to take you to the playlist for DoK Day from London. So you can watch all those videos if you weren't able to attend live. They're all available now, so you can watch them as many times and whenever you want to do that. And we also have all the playlists from all the previous DoK days as well, and as well as all the talks that we post here. So the DoK Day or the DoK YouTube channel is a great resource if you're just getting started and you want to watch a bunch of videos to learn some use cases and to learn a bunch of new stuff. And I'm excited to announce that DoK Day will be back at KubeCon North America 2025. So we're excited that we're invited back. That's going to take place on November 10th in Atlanta, Georgia. And the CFP is open now, actually, and until June 30th. So you have about a month and a half, actually almost exactly a month and a half to get your proposals in. So you can see here's a list of the topics that we're looking to hear about. So app development, how to enable data applications, especially for ML AI streaming and analytic workloads. So we're interested in hearing about that. Emerging and advancements in DoK space. Also DoK Day 2, improvements lifecycle management. So any of that. And then of course, we love to see use cases and best practices. So if you have an interesting use case and you want to share it with the community, this is a great place to do it. So you can scan the QR code there. That'll take you to the page, which has more information about how to submit your CFP, some important dates. So yeah, we're excited to be invited back. I think this will be our fifth co-located event with KubeCon. So it's excited they keep bringing us back because they see the value in hosting DoK Day. And if you're interested in sponsoring, by the way, if you know somebody, you can reach out to me. You can also reach out to Melissa Logan on Slack, LinkedIn. My name, I forgot to think, I don't know if I said that, is Paul Au, last name spelled AU. So you can find me there or, any other channel. Also, just wanted to mention, we do our yearly DoK report. So we are working on the survey for the 2025 report. So stay tuned to that. We'll be conducting the survey in the next month or two to collect data for the report. So we'll announce that on all the channels, Slack, LinkedIn, etc., and also during these talks. Yeah, and then some of our upcoming events. So we had to push back last for our DoK SIG meeting. If you don't know what those are our special interest group meetings, which we talk about different solutions to problems that people are facing, try and fast track some solutions to those issues. So one of the things we worked on was the Get Started project, which was to help people, or Get Started guide, just to help people who are getting started with running data workloads on Kubernetes, just to get situated. So it's kind of a one-stop shop for information for getting started. So we're going to be doing a lightning talk. We're calling it a SIG Spark talk And we were supposed to have it last Tuesday, but we pushed back. We're gonna have a short little talk, and then we'll discuss different projects. And then of course next month for June, so we're hosting it on a Wednesday. Because of Juneteenth is on a Thursday, which is a national holiday, so we want to avoid that. So we're going to host it on Wednesday instead. So that'll be a really interesting talk. So 1 year in production with Cloud Native PG and ZFS on the cheapest case cluster we could find. So that'll be an interesting talk. You can go to our Meetup channel, scan the QR code there, or you can just search for Data on Kubernetes on Meetup, and you'll find our channel. And then, of course, if you're interested in getting involved in the community, you can scan the QR code there. That'll take you to our website, the community page. And if you're interested in sponsoring Data on Kubernetes community, you can also scan the QR code on the right, and that'll take you to our sponsorship page. So yeah, that's it for me. I'm going to hand things over to Vigith and Sri from Intuit. If you have questions, you can post them in the chat, and I will pass them along to them. And we'll get those questions answered at the end of the talk. So, but feel free to pass them along. If it seems particularly pertinent, I'll add it to the chat. And if Sri and Vigith feel like answering it in the moment, they can. Otherwise, we'll get those questions answered at the end. So yeah, I'll hand things over to you two to get started.
Thanks, Paul. Hello, everyone, and thanks for inviting us back to the community again. We actually, quick tidbit there, like we actually started out our open source project quite long ago, but our community engagements actually kickstarted with Data on Kubernetes community itself. So we are always excited to be back and then share about the updates on the project.
Awesome.
Thank you for inviting us. So let me share my screen quickly. Perfect. Hello, everyone. My name is Sri, and I have Vigith who's joining us today, and we are from Intuit, the Kubernetes platform team. I'm a staff product manager, and Vigith, would you like to quickly introduce yourself?
Thank you, Sri. I'm Vigith. I am a principal engineer who mostly work on abstracting stream processing and also the infra.
Awesome. So for today's session, we actually wanted to share a little bit about Numaflow and where Numaflow plays a role in, and essentially in the context of event processing, like how do we scale event processing or event consumers on Kubernetes is the entire conversation is going to be all about. And here is the high-level agenda for today. First, we are going to quickly talk about what Intuit platform does and how we contribute back to the open source and things like that. And after that, we'll just introduce about what event processing means, what are the challenges that developers are seeing on a day-to-day basis at Intuit. And after that, we'll share about Numaflow, do a deep dive into how you can use Numaflow, how it works, a little bit about the architecture, and at the same time, we'll share some of the case studies and demos on how we are also using it into it, Numaflow. So with that, moving on to the next section, which is basically, as we said, we are from the Intuit platform team, where all of our products, like you know that Intuit is a global fintech company offering products like TurboTax, Credit Karma, QuickBooks, and MailChimp. And all of these products are completely run on the Kubernetes platform that we run at scale at Intuit. And you can look at the scale at which we operate, supporting close to 100 million customers. Like recently we finished our tax season, and then you can look at the kind of tax refunds that we send back to all of our customers who file taxes with TurboTax, and then think about the invoices that we process through the QuickBooks, and then also the payroll that we run through QuickBooks as well. So you can look at the kind of scale that we operate in as a platform company. And we are also big believers in open source. It's not just as adopters and usage of open source. At the same time, we are also huge contributors back to the open source. Like here are some of the projects that we have open sourced in the past. If you are from the Kubernetes community, like you might be aware of Argo. Argo is like widely used either for your deployments, workflows, and hundreds of use cases. And that was the project was incubated at Intuit and then open sourced for the broader world. And similarly, we have open source few other projects, and the one we are going to talk about is NumaProj, and specifically Numaflow today. The genesis of the NumaProj project actually started out with some of our learnings from Argo workflows, where the community was looking for, hey, we want to run workflows based upon a stream of events or streaming data that is coming in. Like, how do we go about solving the problem? So that was a gap that Argo workflows had, and that's how we started our journey with Numaflow. But that has evolved into multiple use cases, and that's what you're going to cover today. So with that, I'll be touching upon what event processing means and what event-driven architecture means. So as of today, like across the board, we use a lot of event-driven architecture on a day-to-day basis. So what do I mean by event-driven architecture? Maybe it could be our applications or sensors or any of the different kinds of touch points either your customers have or devices have. They emit a lot of events, and some of the events you would want to process them asynchronously as they happen. So that is where the entire event-driven architecture comes into play. And like you can think of different kinds of sources. It could be your mobile, where either probably you're placing some orders on Amazon, or maybe maybe some sensors sending some events. All of these events generally are transported to different kinds of messaging queues. Could be like Kafka or maybe Pulsar, SQS, and different kinds of messaging buses or queues. And after that, you would want to process these events like based upon the needs and the use cases that you have. Either it could be like placing orders, or it could be some anomaly detection. It could be a number of use cases that you may have. Like essentially, you receive the events, you would want to process them as they happen. And then lastly, you would want to, once you process them, you would want to write it back to some downstream. Either you have some dashboards where you would want to reflect all of that data, or probably you want to send these events to maybe downstream services, which you are communicating, which they consume these events again and then process them furthermore. So on a very high level, it's just like as the events happen, you would want to process them asynchronously and then move it on to the downstream services with whatever is dependent upon. So that is where on what do we mean by like event-driven architecture at a very, very high level. So let's take it some of the examples that we see on a day-to-day basis, right? Like one of the example that I've already touched upon is like e-commerce order processing. Let's say I have already placed an order on Amazon, but in the backend there are hundreds of things that happen. One is it goes and updates the inventory. The second is it runs some payment transactions. It sends out an email or notification that your order has been shipped and all of these. So these are like event-driven architecture that you would see on a day-to-day basis, especially on the e-commerce side of things. And similarly, probably if you are from the IoT space, you would be aware of like predictive maintenances. Maybe based upon the temperature of a sensor, you would want to call some shutdown protocols and like whatnot. So that is also an event-driven architecture there. And smart traffic management, probably you're at a signal based upon the traffic, you're trying to regulate the traffic, turn the signals on to green and things like that. And then similarly for motion detection and whatnot. So on like right from like e-commerce to industrial to fintech, like the way we Intuit, across the board, you would see event-driven architecture. Like they are the backbone of our modern tech on a day-to-day basis. So these are some of the examples that you would see with respect to event-driven architectures on a every day. And then moving on to like, what do we see as challenges with event-driven applications? Like some of the things that we have touched upon is, hey, you have these multiple sources that are coming in, like you want to process that data and then finally move the data to the downstream. But as a platform team at Intuit, when we started having conversations with all of our developers, we tried to understand what are the challenges that they encounter every day. So the first and foremost is like in the earlier architecture diagram that I've shown you, like if you have multiple sources, let's say you have Kafka, which is sending the events to you, you have SQS that is sending the events to you, you have Pulsar and all of that. So what we understood from our developers was they were spending a lot of time in writing the boilerplate code just to connect with any of these different kinds of sources. So if as a developer, ideally, I would want to just write that processing logic, not worry about this boilerplate integrations and like even the downstream integrations and things like that. So our teams were spending a lot of time in like writing this boilerplate code. Some quick stats to give you there is some of the teams were spending anywhere between like 3 to 5 days to integrate some of like when you have multiple sources. And we were able to, we'll share some of the stats as a case study towards the end. But like you can think of the challenges that the teams face, like just with the integration point of view itself. Like they're writing a lot of boilerplate code. You have to connect to multiple sources, manage them, and all of that too. And the second thing is auto scaling. So when you're running these event consumers on, like if you have developed any Kafka consumers or maybe Pulsar and things like that, when you're running them on Kubernetes, one of the challenges that you would definitely encounter is how do you scale these event consumers at scale based upon the number of events that you are receiving. So one of the shortcomings of like the Kubernetes like HPA is that it looks at CPU and memory utilization, essentially the resource utilization in order to horizontally scale your pods. But that would definitely not work for your event consumers, because you would obviously want to scale based upon the number of pending events and the events that you're receiving from your upstream. So that was one of the consistent pain point that not just our developers, our even DevOps teams were also complaining a lot about. So again, like to share some of the stats there, like some of the teams used to scale a couple of times every week and scale down a couple of times sometimes even on a day-to-day basis. Let's say, for example, you can think about QuickBooks. QuickBooks as a product is widely used in North America and then probably in Europe and few other regions. There would be always a particular period of time during the day where you would not see a lot of data flowing in to start with. So ideally, during those times, you would want to scale down so that you're not essentially wasting any resources and then not underutilizing all of your resources and things like that. So we started seeing scaling complexities. And then lastly, one of the key pain points with respect to event-driven applications is that definitely teams would want to understand how is the event flowing through and where is the lag coming from. Yes, of course, you're receiving a lot of events from your upstream, but at the same time, at what rate are you processing them? Like, where is the bottleneck? Is it consumption taking time? Is my processing taking time? Is it me writing to a downstream taking time? That was one of the key pain points that our teams consistently were looking for. So across the board, in short, like teams were spending a lot of time in writing a boilerplate code instead of writing the processing logic. They were focusing a lot on the operational excellence, like manually scaling their pods up and down so that they don't have any consumer lag and things like that. And then lastly, they are also spending a lot of time in figuring out how do we go about debug when there are latencies involved and all of that. So with that, I would want to pass it on to Vigith and how we went about solving all of these challenges using Numaflow. So over to you, Vigith.
Thank you, Sri. So let me start. You see my slides, and I'm gonna.
Yeah.
You see the big screen on the slideshow, right? Yeah. So, thank you, Sri, for a wonderful introduction. I'll talk about how we solve these problems and open source this project, so that the community can benefit from the work we have done and helped us internally at Intuit. To start with, right? So the way we saw event processing was we wanted to take a serverless approach for the whole event processing. The first and foremost is what we found out that is in Kubernetes native systems, right? Users are more interested, the core developers, right? The DevOps is very interested with how the infrastructure works, but the developers are more interested about writing their application logic and making an impact to their customers, right? For Intuit, it will be the users using TurboTax, QuickBooks, and things like that. So we wanted to abstract the infrastructure completely from our developers so that they can focus on what they love the best, that is delight the customers by writing code that makes an impact, right? So first and foremost, we abstracted the infrastructure. Second is we also extended to decouple the development code or the business logic from the source and the sink. What it means is that users shouldn't care how you connect to Kafka, because there are a lot of set of rules in how every company enterprise they talk to Kafka. For example, at Intuit, it's not a simple Apache Kafka client which we use. We have our own distributed Kafka clusters where you can failover between, and we can even failover between cloud providers. So we have multiple Kafka clients that's being created behind the scene, and then every data on wire is encrypted and so forth using custom encryption systems. Users shouldn't care about those because for all they care about is how do they process the data in Kafka or the data given to them rather than how to connect. So we wanted to let the same code work immaterial of how the upstream being the sources are working, right? And lastly, we wanted a system that is cost efficient, meaning auto scale from 0 to many and back to 0 if need be. That comes along with elasticity and no downtime upgrades, so that there won't be any tail latencies involved or incurred when you are having some security patches, for example. And it all should be done behind the scene for the developers, so they are completely focused on application development. So earlier we started off with Numaflow little differently, right? But when we were experimenting with Intuit, we found many use cases are all about reading from sources, possibly doing some transformations and writing to a sink. Sink could be database, could be writing to some other Kafka topic, writing to a blob store. And actually, this diagram also could extend to show a fallback sink in case the sink is down for a second. So basically a built-in DLQ system, right? So this is something new we developed recently is a simple event processing system that can auto scale by itself without any complexities of multiple vertices. So there's a source, you process, then you write to sink, and they can auto scale based on the same rules on how much is pending at what is the lag of your consumer, or how many messages are pending at source for SQS or Pulsar and things like that. Right, so this is the simple one. This is the most popular Intuit. Around 90 teams use this symbol system. Now, the original Numaflow was for complex event processing because we were more towards data and AI/ML. What it means that the previously you saw one box, which is a vertex, but this is a collection of vertexes where we give guarantees about no data loss, retries, and everything from the source, that meaning from the source all the way to sink. And each of them are a single vertex that can auto scale and even can do custom placements. For example, you can place this UDF on a GPU and because you are doing some inference, things like that, right? So this is the original Numaflow which we built, and the one which you saw before was the simplified version, which is mostly what simple processing requires. So let me talk about the complex one, and the same code will work. You do not have to change your code between a complex or a simple one. It's just a specification change. The code remains the same. So users can switch between each of them as they feel, as they see fit for them. So in here, we read data from the source, we track event times, watermarks. Then we pass it off to UDF. This is user-defined function. This could be generate 0 or many results. It could be a map function, a reduce function, or in some extreme complex scenarios, we even give something called a accumulator concept. So it could be any of the UDF you put in there. Once the UDF has processed, you can do conditional forwarding. For example, you can say send this message to the left vertex or to the right vertex or to the both. This is a runtime decision you make based on how you process the data. And eventually you write this data to a sink. It could be a streaming sink. For example, you might write back to Apache Pulsar, Kafka, or it could be a blob store, like uploading to S3 and things like that. So this is how a complex system looks like, a Numaflow DAC looks like. Let me show you how the processing looks like. So if you look at this is a symbol, a symbol code that shows what does it need to implement a symbol UDF. Now, if you look at the signature here, right, the datum abstracts where the source is. You won't see even error in the messages. It's because platform takes care of error retries, making sure that if a pod gets restarted, we retry the same message and so forth. So the developer is given a datum and they have to return a set of messages. This goes to the theory of one or more messages, for example, for flat map operations, right? So the way you do it is first you create a return envelope, that is messages. Then you do datum.value, which will give you the payload that is put in the source. It could be a payload inside Kafka, and you could do datum.get headers to get the headers in Kafka. If you replace Kafka with HTTP, datum.value will be the body, datum.headers will be the HTTP body, HTTP headers. Then you do your processing function, right? You take the event, you do how much ever time you want to take, right? For if you're doing some complex AI, this might take even minutes. But if you're doing very simple operations, in-memory operations, it will be microseconds. You do not have to worry about how long it take. We understand this and we auto scale based on how much it took because we understand the processing time of the system, right? Then you put the result in, you return the message. That is it. Don't worry about error retries. Don't worry about back pressure. How many of them should be running? These are all taken care of the platform. Hence, we are abstracting the platform from the user. From a user code, they just write the business logic. And I just want to call out that when you process the result, right, you could actually append a message saying that when you create the message, you can tag it saying that either send to the left or right. This is basically how dynamic routing works. Now, with these two concepts, which I told earlier, right, you can build very complex tags. You could have multiple sources, which is writing to a single sink. You could have multiple UDFs writing to another UDF that basically join, writing to a sink. You could have multiple sinks. It doesn't matter, right? You could even have cycles. So we are no longer a DAG. We are mostly a DCG kind of system where we do dynamic compute graph, directed compute graph rather than acyclic graphs. You could have cycles if need be. And lastly, you could even have broadcasting. So the triangle, what it means is that these systems are streaming systems. Once that is mostly like a fire and forget system, where you configure the pipeline, you forget about it. Technically, you can forget about it because we auto scale based on the traffic. We take care of pod, node migration, everything, right? But how do you reconfigure the system? For example, you want to change some configuration, right? That is where we give this broadcast. So you can broadcast a new configuration, and every vertex or the vertexes that are interested in that configuration can absorb it. Now let me talk about, I talked about UDFs. Now it's very easy to write even your own source. So, and here I'm putting, we are language agnostic. That's the reason I put the language symbol in here, just to show that earlier I showed a Python code. This is how you implement your own source in your own source. And anybody who implements read, act, pending, and partition can be a source, right? And we take care of guarantees. For example, how the watermark propagates, you don't have to worry about it. We internally take care of all this. All you need to do is implement the source interface, or in Rust, it is implement the source trait, and you will be source trait, and you will be able to build your own sources. Basically, it says that, hey, how do I read a message from the upstream? How do you acknowledge a message? How many are in the upstream, pending, and the partitions? Same about, so this is an example in Java about how to implement your own sync. In sync, if you see, you are given an iterator rather than data, because there are many cases you want to do batch updates, right? But you are given an iterator, and the iterator will close when the batch has met, and this function will be invoked for every batch. So I'll talk about a very high level architecture. This is extremely high level. Okay, so the data moves from left to right, meaning you read from source, and the data keeps propagating. And in the same time, we have back pressure that moves from right to left. So this is the back pressure where what back pressure means is that your producer is faster than your consumer, or other words, your consumer is not able to keep up. And based on this information, we know how to auto scale. Right. So if you think about it, you read from the source writes to a raft consensus system. This is to make sure that no message is lost whatsoever. And every vertex is in between they talk through raft. And that way, there even during restarts or hard kill, sick kill on a container, right, we still are able to recover without any data loss. And then data goes to data sync. There is also a concept of watermark. This is mostly for reduce use cases, so that we have a completeness property associated with the pipeline. So you can do things like, I want to do group by 1 minute, group by, or do sliding windows, or even in complex cases like session windows, things like that. That's where we use watermark, and these are all built in the platform. So developers do not have to worry about, business developers do not have to worry about implementing them. So to summarize, what is Numaflow, right? Numaflow is a Kubernetes native serverless platform for running scalable and reliable event-driven pipelines applications. First and foremost, it's very lightweight. It is fully featured with respect to streaming semantics, can be deployed on edge and on-prem. A lot of users are running. Sri can talk about it. I'll let Sri talk about who is running and how they are running it. Right. The key point is very native to Kubernetes, meaning we extended Kubernetes to get Numaflow working by having our own controllers and things like that. Language agnostic, you'll see Java, Python, Golang, Rust. We even recently added Node.js SDK. And it's very easy to write connectors, for example, sources, UDFs, and things. As you saw, just implement the interface, you will get those. And lastly, scalable and cost efficient. It supports auto scaling from 0 to many based on back pressure, and is very lightweight. And the resource usage is very low. meaning you can easily run it on edge. The core of Numaflow, the 1.5 which is coming out, many of the components have been rewritten in Rust so that the both memory and CPU footprint is very, very small. With this, I'll hand it over to Sri so he can show you a few demos and talk about our community and users.
Thank you, Vigith, for giving a quick intro about how you can use Numaflow, how it works internally. Let me share my screen back again so that we can quickly show you a demo of how we are using it into it and various use cases on how the community is also using it. I hope you can see my screen, right?
I cannot.
Not yet.
You're not sharing it.
That's good. Yeah.
There you go.
Thank you. Perfect. So as a platform, we also come with an end-to-end development lifecycle using our UI and the platform itself. So the first example that Vigith has focused upon is the simple event processing use case, right? Where you want to use only one vertex, which has both the source, the processing logic, and writing it to sync in the same place. This is primarily useful for simple event processing use cases where you just want to move the data from one source to a sync. We have been seeing a lot of adoption, especially with the simple event processing at Intuit. Earlier, we started our entire journey with the stream processing use cases, but event processing, like simple event processing, is also something that everyone was looking forward to because the existing solutions out there either are really complicated to deploy, manage, and operate. So that is where entire the simple event processing, or mono vertex is how we call it as part of Numaflow, was developed. So this is like one of our production mono vertex that is running at scale. So this particular mono vertex, if you see that you have a source container and then you have a sync container. So essentially all of the processing that they're trying to do, they're just consuming the events from Kafka. And then they are writing all of those events, the processing logic, everything in a sync itself. They are not adding any transformer steps in between. So that says that it's very pluggable. Like if you have a need for adding a transformer, you can just bring in the transformer. And then if you don't want it, you can just remove. But the simple semantics is that you just need a source and the sync, and you can write the processing logic in any language that you'd like. So here, this particular mono vertex is like running 3 pods and constantly processing like close to 1500 events per se. But the mono vertex can absolutely go up till like 250K. So internal testing that we have done. So it's so lightweight that one single part that was processing, it could scale up to like 250K TPS as such. So it's a very high throughput system where you can, if you have simple event processing needs, you can definitely go with like mono vertex. But it's not just about helping you create, and so our intention is also to observability side of things, and at the same time scaling and all of that pieces. So in the UI itself, we also help developers with how to go about debugging if you are seeing any of those issues. So with the UI, you have, let me go with the first spec, like how does this definition of this mono vertex look like, and then how rest of the tools, the functionality and the features that we have. So here you can look at this spec in itself. Here it says that you have 3 replicas for this particular mono vertex. And then if you look at this first step, right, this is the standard event bus, so essentially our Kafka source that we have internally developed for Intuit needs, and then just giving it to the team. So no one will be writing any of those integrations with Kafka. Rather, they'll just be using this image, and all they would be focusing on writing their processing logic, which would sit in this entire the sync container itself. So essentially, in short, like we are letting the developers to write and focus on the processing logic instead of the integrations with like Kafka or any of those pieces. And at the same time, you can also specify all of your needs in terms of resources, and all of that can be all of the Kubernetes semantics that are most important for you are exposed to you. You can add all of those constraints and everything. And then similarly, you can also see the scale part of it, right? Like here, this particular team has said that min is 3 and max is 3. Ideally, teams don't even have to do that. We can absolutely scale down to 0 and then to your max partition count if it's Kafka, based upon the pending events that we are seeing in your Kafka topic, and at what rate are you processing that. So it's completely auto scaling taken care by the platform for the developers. So this is how the spec looked like. But at the same time, we also said that observability is one of the pain points that the teams generally tend to have. So what we do is we provide all of these logs and metrics pretty much close to where they are. You can quickly take a look at what is happening with your source, what is happening with your sink, or any of those containers within that one vertex in itself. So some of these are internal related vertices, but Numa container is what takes care of the data movement from your like the source to sink and all of that pieces. So essentially that's the core platform in there. As a developer, if you are interested in looking at your logs, they are right here for you for a quick lookup. And all of this is available open source. You can take a look at the product and anyone can use the same features, not just Intuit. Similarly, we provide a lot of metrics. Like one of the key things that the teams tend to have is like, hey, how many pending messages do I have? What is the processing time latency? What is the sync writing time latency? Like all of these are the constant questions that earlier they would have to emit custom metrics and then try to create dashboards and all of that. So this is where we have simplified the things quite a lot, like where we provide the most important metrics in here itself, right? From like resource utilization to pending messages and all of that. So it's pretty much baked into the product in per se. So this is the simple or the mono vertex side of things. But we also said that we also support really complex use cases where this is a really complex pipeline. This is our real-time anomaly detection pipeline where we understand how our customers are actually using the product, maybe QuickBooks and TurboTax and all of that, and then see, hey, are we seeing any errors or any anomalous patterns in the usage or things like that, so that we can notify our development team saying that, hey, we are observing some anomalous patterns, please start looking at your errors, and then we create incidents automatically and things like that. So this is the real-time pipeline that is taking care of that entire infrastructure doing the anomaly detection. So this is where the entire, you can go from like a simple mono vertex where one vertex takes care of everything, the source, sink and everything, to a very complex one where you can break your processing logic into n number of steps, and you can also actually add multiple sources. Let's say, for example, you are receiving events from Kafka, maybe you're receiving the similar events from maybe SQS and things like that. You can definitely add more sources. So it's very complex. You can build very complex cyclic graphs as you wish. So I'll quickly go through some of those pieces, right? So here, the events are being consumed via Kafka, and then we are doing some pre-processing steps before we send it to some anomaly detection models. And also we are using the same pipeline in order to trigger some of our ML workflows too at the same time. So here after pre-processing, we are doing inference, and then we are doing some post-processing here, and then we are sending the data to multiple sinks. Like one of the sync that we send it to is our observability tool called as Wavefront. So we send all of our data to Wavefront for alerting needs and dashboarding needs and whatnot. And similarly, we also send the data back into a Kafka so that it can be stored in our operational data lake and things like that. So, but one of the key things that I'd like to highlight is like, you have seen that you can add multiple sinks, you can write n number of processing steps as you wish, and then you can also add a number of sources if need be. But the key things that I'd like to highlight here is like the auto scaling. So we spoke about back pressure, we spoke about, hey, auto scaling is done per vertex and things like that, right? So here is the, let me quickly refresh. And you can see that for the source, you have like 4 pods provisioned. You have for ML pipelining, there are 2 pods, and then pre-process has 2 pods, and then inference has 3 pods. So it's not a uniform auto scaling that happens for each and every vertex. Rather, we do auto scaling per vertex in itself because we understand how many pending events are there at a vertex level, saying how many events are flowing through, what is at what rate are you processing those events, so that accordingly these pipelines or the vertices will be scaled up. Maybe during this demo itself, sometimes you'd see the number of pods might be changing from 2 to 3 or 3 to 4, like things like that, based upon the events that we are receiving. So everything is done for you. And the second thing that I would like to highlight is this is where your development teams, ML teams, everyone can come together in order to make your anomaly detection pipelines or any of different kinds of pipelines make work together, is because some of these steps, let's say the pre-processing steps are actually written in Java. The inference steps are written in Python, and there could be other steps written in Go as well. So it's a very polyglot pipeline. So any team that is interested in, like, let's say one specific team focuses on just writing the pre-processing logic, another team focuses on the ML side of things. So this simplifies a lot because each of their team will focus on their own skill set that they have. They can write each of these steps in any language that you support, because we support SDKs right from like Java, Python, Go and even in Rust, because stream processing across all these languages, there is no platform out there that supports it. So that is what really resonates with our community as well. So I'm going to share some of the use cases very soon, but it's a very polyglot approach of creating or writing your stream processing pipelines is where entirely Numaflow shines in. So this is again like similar debugging features. Everything will be available at what rate you're processing them. Like the spec is going to change is going to be a different, but you don't have to change your code if you're moving from simple event processing to like the complex event processing. So you'll have the similar metrics available at the same time. So that's in short about quick demo of like how we are using Numaflow at scale at Intuit, not just for like anomaly detection, even for some of our the simple event processing use cases. The other one, which I actually showed you, this is supporting QuickBooks. I cannot share a lot more details about it, but I can definitely say that, hey, this is really powering our production traffic right now for QuickBooks is what I can definitely say. So you have simple event processing, and then you have the pipeline use cases that can be definitely solved by some of the insights are like as a case study where on how we are using Numaflow and what are some of the benefits that what the teams have seen. So like as I mentioned earlier, like one mono vertex with one pod, like you can see that it was scaling up till like 260K events per second. So it's very lightweight. With one pod itself, we can absolutely crush all the events that are coming in. But at the same time, here are some of the benefits, like some of the teams that have seen. So one specific use case where earlier the team used to take to process close to 1 million events, they were taking anywhere between like 20 to 25 seconds in order to process those million events. But after adopting Numaflow, their entire processing time has reduced, like the TP95 value has reduced down to like 0.5 seconds in itself. So you can see a 60x performance that they have seen. And the second is they were able to scale. Like earlier, what they had to do was they used to have one consumer that they have really custom built that would be consuming from multiple topics and all of that, where they had to write this integration logic again and again, and then multiple complexities that they had. Now with monovertex, and what they had to do was just like spin up a new monovertex per topic, or if they want to consume multiple topics in using one monovertex, you can definitely do that. So it made their life easy in order so that they don't have separation of concerns. They don't have noisy neighbor issues, and then like things like that. The third one is around auto scaling. So auto scaling is the biggest bang for the buck that the teams have seen is around. It's not just about developer productivity; it's also about the cost at what we are operating. So this particular team, what they were doing was they had one consumer that was consuming from multiple topics that was always had static set of pods. Let's say, like, let's assume that they were always at n. Even the traffic dies down, the pod count always stayed at n. They were seeing a lot of resource underutilization that was happening, and it also leads to cost at the end of the day. So by adopting Numaflow, they were able to reduce their cost by like close to 40% just for like one use case in itself. So think about the n number of use cases that Intuit at the scale that we operate. So we do definitely have a lot of cost benefits just because of adopting Numaflow. And then lastly, observability is also key because once you're deployed, you also definitely want to understand what is happening with your system, where the bottlenecks are, and things like that. So we provide out of the box metrics and the UI that I've shown you earlier on. So that helps them to quickly debug and then fix things as they happen. So this is like how Intuit is benefiting from Numaflow. There are multiple teams that are adopting right now. We have close to, like as Vigith said, like close to 90 to 100 teams that have already onboarded, and then pushing for a lot more as we go. So this is more about how Intuit is using it. But let's also learn a little more about how community is also using Numaflow at scale. So because we are open source, like once it's open source, there'll be a lot of people who are interested in using the product for different kinds of use cases. So that is what you would see here, right? Like right from fintech to aerospace, you have use cases right from simple anomaly detection, simple event processing to complex things like IoT data processing, and then accelerator chaining and things like that. So I'd love to touch upon some of the use cases that some community members are using Numaflow for. First and foremost, like you can think of Lockheed Martin, they're into aerospace. They use it for like some of the IoT data processing, specifically for some of the needs that they have. NTT actually is a very interesting use case where they actually use Numaflow pipelines specifically where they break down their entire pipeline into multiple steps. You have a pre-processing steps, you have inference steps, and then you have post-processing steps. But ideally, your pre-processing and post-processing generally need CPU resources, but your inference would need maybe GPU resources. So essentially, what they're using these Numaflow is for like breaking down processing steps and then ML pipelines into multiple steps, and then use ideal or the optimal resources for each of those vertices. So you can specify, hey, for vertex A, use CPU resources, for vertex B, use GPU, or if you have different kinds of resources, you can definitely use that as well. So we have a blog post that entity team has shared yesterday. We'd be more than happy to share with the community on how they are using Numaflow for their use cases. And similarly, there is another one which is like BQ. This is another really interesting one where they are doing digital signal processing, where they receive a lot of radio frequency signals, and they want to process all of these events on edge devices, which are completely cut off from the internet. So these are the various use cases that we have heard from the community, and there are a lot more on how they are using Numaflow. It could be either simple event processing or ML workflows or even stream processing use cases across the board. So this is what we definitely support as a platform end to end, and what we use internally is what is available for everyone out there too. With that, moving on to our last, if you are interested in trying out Numaflow, definitely be part of the community. You can be part of the community in multiple ways. It's not just about using it. You can also contribute. There are a lot of open issues that you can contribute to. If you are interested in trying out Numaflow, you can definitely you can scan the QR code. It will take you to the GitHub repository. If you really liked our presentation, do give us a star. And then we also have a link to a Slack channel on that. Definitely join if you are interested. So that's a very short, a very high level demo on what Numaflow is, how we are using Numaflow within Intuit, and at the same time how Numaflow is being used by the community. That we'd be more than happy to take any questions if they are out there, Paul.
Sure. Okay. Yeah. So if anybody has any questions, now is the time to ask them. I'll let that see if anybody asks anything right now. But so what are sort of the next steps? Like where do you see things going in future iterations of Numaflow?
That's actually a very good question, because we do have new releases that are coming up with Numaflow in 1.5, specifically around some of the use cases that the teams had with respect to ordered processing and things like that the community has requested. Those are some of the features that are coming in, and we also have much richer debugging experiences that are also coming out. But Vigith, do you also want to touch upon the serving feature that we are going to release very soon?
Absolutely. So, what we are seeing with in the event-driven processing is lot of LLM and agentic development are happening on an asynchronous fashion, right? So, and Numaflow is agnostic to these things, right? So it can actually mold into solving scalable agentic workflows, and we see at Intuit that that is another area where Numaflow is shining. Right. The language agnostic help a lot because data comes through Kafka, but most of the LLMs are or Python experiments, LLM experiments or agentic experiments are written in Python, right? So language agnostic help, and the auto scaling ability to scale differently based on and the GPU placement, right? For inference, we need a different set of criteria and placement policies. So Numaflow is being used at Intuit. And maybe in one of the future meetings, we can go into a few agent use cases, how we are using. That also opens up a new problem, right? Today, if you look at Numaflow, it's all about left to right. You read, you process, you write out. What if you want to do it as an HTTP-based system, where the user makes a call? Let's say you want to have a chat app, which is LLM powered. How do you implement a chat using Numaflow? Right, so that is about 1.5. It gives you an HTTP endpoint, and you can make a query, and the DAG will be executed. Sorry, the graph will be executed, and the response will come back in the onto the source itself. So 1.5 is something which we are eagerly waiting for to release, and we rewrote a lot of things also from to make it more efficient in Rust, the internal code, so that it's even lighter in footprint and much more reliable.
Awesome. All right, cool. Well, people are being shy today, so we don't have any questions from the community. But of course, you all are available, there you can find Sri. I don't know if Vigith, are you on the DoK Slack? I forget.
I do not think I'm on.
If not, it's okay. You can reach out to me. I can pass the questions along. I'm sure you can find Sri and Vigith on LinkedIn, and Sri is on the DoK Slack. So if questions come up, you know where to find them. And yeah, I really just want to thank you for presentation. It's really awesome to see all the advancements and the updates that have been made since we last saw you a few I don't know, a few months back. So thanks again for your presentation. Really appreciate it. And looks like some really awesome stuff going into Numaflow. So yeah, we'll see you at the next time. We'll bring you back. Of course, we'll hear more updates in the future.
Definitely. Thanks a lot, Paul.
All right, thanks. Have a good one. Bye. Bye, everybody.